Hi guys, today's video kind of introduces a scenario that we're going to use for the next couple of days. We're actually going back to discrete random variables. The reason is it's a lot easier to understand kind of the context behind some of the stuff that we're going to be doing if we use discrete, and then we'll kind of see how that translates into continuous random variables after we practice this for a few days. So go ahead and read what's on the screen for a second. So we're essentially going to take a pre-existing random variable and we're going to multiply every possible outcome by some value. And I have a scenario to kind of help us explain why we might do that. So we're going to be working with this guy, Pete. He has a Jeep tour company in Africa. He has kind of a limit. He has to have 2 tourists signed up to run each tour, but the most that can fit are 6. So he can either have 2 passengers, 3 passengers, 4, 5, or 6 passengers. So as usual, what we're going to start off with first is setting up the probability distribution. So we see there's 15% of the time he's going to be ending up with just 2 passengers, 25% of the time he's going to have 3 passengers, so on and so forth. So take a minute, pause the video if you need to, set up the probability distribution, which would just be our little chart that we've been doing in class to represent Pete and his Jeep tours. So here's what it should look like. 2 people, 15% of the time, 3 people, 25% of the time, 4 people, 35% of the time, and so on. So what we're actually going to do next is just find the expected value. So if he were to look at his ratings over many days, how many people should he expect to have on a Jeep tour in any given day? So you could either use the calculator to put these in L1 and L2, or you could do it by hand, because we know that's not too bad. So expected value, use the calculator, do it by hand, whatever, you end up with 3.75 passengers. So he should expect to have 3.75 passengers on any randomly selected day. So again, you can't have 0.75 of a person, but we want to acknowledge that this is an average, so we keep the decimal. So we're also going to be looking at the standard deviation. So even though the mean or the expected value is 3.75, on average, how much does it vary from there? And it varies by 1.09, so that's about 1 person. But again, I'm going to keep the decimal because we know that standard deviation is a calculation of an average. So what I'm interested, oh, sorry, here's the halfway joke. Okay, hopefully you've all seen Fresh Prince of Bel-Air. Moving on. Okay, what I'm interested in is transforming the original distribution. So when you transform something, you change every aspect about it. We actually saw this earlier when we transformed distributions, and it's kind of the same process. So this should sound a little bit like review. So he knows on average he's getting 3.75 people, but how much money is he making on the average day? So if he's charging $150 per passenger and he has an average of 3.75 people, kind of his expected value, I want you to think about maybe how much money he can expect to have on any given day. You might have an idea of how to calculate that, but let's just do it the long way so you can see how it works out. So I want you to set up a new probability distribution that represents the amount of money he collects. So I took 2 people and multiplied it by 150 to get $300 is what he's getting from those 2 customers. If he has 3 customers, he'll get $450. If he has 4 customers, he'll get $600, and so on and so forth. But you should notice the probabilities didn't change. This was still the probability for having 2 people, 3 people, 4 people, 5 people, 6 people. So try and anticipate how much money he can expect to collect. Then take these values, plug them into L1, plug them into L2, and see what you come up with. So if you want to pause the video now and do that, go ahead. So he's going to come up with $562.50. I got that by typing these into L1, typing these into L2, and then finding the average. So obviously, if you anticipated, this is really just my expected value of, or expected amount of customers times that $150. So kind of the bottom line is you are allowed just to multiply the constant to the mean. So whatever constant you were multiplying all of these values to, which was 150, if you just multiply the mean by that, you get the answer. We did see this before, and it is much the same. So what do you think happens to the standard deviation? We could try it. We could look in the calculator. Actually, it's probably sitting right in front of you, so just take a look. But yeah, it's the same thing. So if you get 163.45, that is just from taking the original standard deviation and multiplying it by 150. So that's it. Same thing that we kind of learned from a couple chapters ago. Let me go back. To summarize, if you multiply an entire distribution by a constant, you can change that by multiplying the same thing from the mean and the standard deviation. So the back paper, or the back of your homework paper, has this question. I want you guys to essentially look at his total profit. So even though he was getting $300 when he had 2 people, what I'm saying is he still has to pay money to run the Jeep, to pay for gas and permits, so he's not profiting $300. He has to spend $100 just to run the tour. So his profit would really only be $200. So I got that from taking the 300 and subtracting $100. So I want you to fill in the rest of the distribution. I want you to answer the 2 questions below it, so part B and C, I believe, and that's it for tonight. We'll kind of go over it tomorrow in class. So hopefully you are able to tell me what happens to the mean and standard deviation when you're multiplying the entire random variable by one constant.